So this is a simulation for answering the final exam. We will have this particular exam question, end of semester examination, semester 1, 2022-2023 session. This exam paper will take 3 hours. So if we consider here, we start at 9:30 just now. So 9, 10, 11, 12. So it should be until 12:30 p.m. right? So that's the time, and we will try to, as a simulation, we'll try to solve this problem as a student would in the examination hall, meaning that normally when I do this simulation, the first 3 to 5 minutes is me talking to this, and we'll just go through the question paper, because normally in the final exam situation, that is what is advised for you to do. Do not straightway jump into answering the question, rushing through without first screening through. Make sure you know what the exam question want you to do. For example, do you need to answer all question? Do you need to answer only selected question? For example, how many hours that you are having, how many questions, and which question give most marks, etc. Right, so that you can strategize and allocate time appropriately. So in this case, it is 3 hours, where you have 4 questions. And then let's take a look. There's question 1, 40 marks. So meaning that the distribution is not the same, because question 1, we have 4 questions, but question 1 only already give you 40 marks. So it's quite a long question. Question 2 give you 20 marks. Question 3, 17 marks. Question 4, 23 marks, right? So your distribution of time should be allocated relative to the marks given. That's general idea, right? It's not exact, but so meaning that 40 marks is 40% of 3 hours. So you should solve this within, so 40% out of 3 hours is 3 times 60 minutes, which is 72 minutes, which in 1.25, less than 1/4 hour, right? So that's the time distribution for this one. Of course, for this one, 20% times 3 times 60 minutes, which is 36 minutes. You should be able to solve this one. This one should be roughly 30 minutes. This one is 35, 40 minutes, I guess. So roughly that time, right? So make sure you plan that, write it on your side or something, so that you are on track on the time management side. Alright, now in terms of the nature of the question, let's take a look as well. So if you see here from the drawing, this is like a rigid body question. So you have to find support reaction, normal shear. Okay, this is internal loading. What will happen? Okay, this is normally marks like this is tend to be comprehension question. It's just a statement of answer, right? Normally. And then here is a frame, I think. Is this a frame or machine? But regardless, it's the same way of answering. So you need to find the unknown of load or weight or mass, right? So there's 2 mass here. One will be given, one will be needed to be calculated normally. And then question 2, this is friction. From the diagram, I think you know this would be a friction problem. So you have to find the weight, find the, what is this? Coefficient of static friction, which is mu, right? And question number 3, you have this one. By looking at this, you know you have to do integration. So make sure going into the final exam, you already, integration is something that you can do easily. So determine the centroid and also determine the moment of inertia. So of course, chapter 9 and chapter 10, both chapter can have integration questions. So here you can see that. While this one is a composite area, and then you need to find the centroid. And then this one is a bit different, center of mass, but this is also composite, and it's a combination of line, right? Alright, so that's the question. So without further ado, let's go into question number 1. By the way, I'm a bit sleepy and tired, so I didn't really want to do this morning. However, I thought that in reality for student as well, you may go into the final exam not really, you know, full. It's best if you can plan so that you go into the final exam fresh and energetic, right? But if even if you are not as, you know, you have a bit of sleepiness, etc. If especially if somehow you have to study last minute, right? Hopefully you plan you know, ahead. If you are watching this and the exam is far ahead, please plan properly. But if you know it's tomorrow and you are preparing, you have to be able still to do well under these circumstances, right? So yeah, so that's why I decide let's just do it. So if you see here, we already used 7 minutes to prepare. Of course, in the actual exam you will not use this much because you will not be talking to anyone like this, but you have to actually screen through, find have the idea of how much time. So if we have already used that much time, this one should be around, let's target it in 1 hour, we should be able to solve this one. All right, so question number 1. Question 1. So in question 1, of course, we have A, B, C, D. Okay. So determine the support reaction forces at pin support A, roller B. Okay, so this is pin support. You have AX and AY, and then you have normal reaction at this roller, right? Now, here you can see also you have this, how to say, distributed loading, right? Distributed loading. Okay, so yeah, so let's, okay, because we only have limited space here, so I hope you can still see this one, and we need to find support reaction at both places, right? So basically, if you draw the free body diagram, so the outline of the body from point A to point B, right? And of course, if you draw the support reaction first, so you'll have AX and AY. Of course, the direction is assumed, and then you have this 9 kilonewton downwards, 9 kilonewton, and then this distributed loading, and you can see that the distance is 4, so in the middle here is there, so there. And then in terms of value, so it's just the area, right? So 12 kilonewton per meter times the distance of 4 meter, you'll get what, 48 kilonewton, right? In terms of distance, this is 2, so you have this is 2, and then because this is another 2, right? So and then this is 4. So that would be the free body diagram. Oh, sorry, the support reaction at B is not yet drawn, so you have normal reaction at B. What else? So you have all the forces, yes. You have the support reaction unknown, yes, and then you have the dimension. That would be the complete free body diagram. Now, to solve this, you can just use the summation of Fx, summation of Fy, and summation of moment. Normally, the easiest way to start is summation of a moment, and then Ya, because we have a point where two forces coincide. Of course, if you select point B as well, you can solve for Ay. So either way. So let's take counterclockwise as positive. So moment about point A here is 0. So NB is counterclockwise. So NB times the distance of 4, 6, 8. So 8. And then this is all clockwise. So minus 9 times distance of 2. Minus 48 times distance of 6 equal to 0. So by this you should be able to solve for NB, right? So 9 times 2, 48 times 6, 306 divided by 8, 153 over 4, which is 38.25 kilonewton the unit, right? What we didn't, okay, it's best if you write somewhere elsewhere what you need to find. Okay, in this case support reaction, right? So NB is solved, so you need to solve for AX and AY, right? So next, summation of Fx equal to 0. Let's take to the right as positive. So okay, because there's no other forces, so this is the answer. This is also the answer, because ax is only the only component of the only force in that have x component, right? Summation of fy equal to 0 if you take positive upwards. So you have ay minus 9 minus 48 plus nb, and nb is 38.25. This should all equal to 0. So ay 948, and then nb, which is 38. Then where's my mouse? From here you have minus 9 minus 48 plus 38.25, and then 75.4, which is, where's my ay is 18.75 kilonewton. Alright, so you have already the three answer for the support reaction. So that's okay. This is actually part A, right? This is question 1. Let's write it this way. Question 1A. Alright, moving on to question 1B. Question. I hope you can still read my lousy handwriting. Okay, so question B. Hopefully you can see, but I'll just maximize first. Oops. Determine the normal force, the shear force, and the moment at point C using the left side of the beam AB. Alright, so this is internal loading, because of course the internal loading have that three component, right? The normal, the shear, and the moment, and it's specified at this point C. And in this question, actually interestingly, question B and question C is the same, because you need to determine the same thing at point C. But one is the using the left side, meaning because if you cut off at that point C, first you have to solve using the left side, next you have to solve using the right side. But if you understand what you are calculating, the answer of part B and C should be the same, right? So let's take a look. Alright, so we need to draw the free body diagram, and you cut at point C, right? Meaning that if you refer here, you cut off here. So free body diagram. Okay, you cut at point C, so meaning that it is from A to C, right? And then you have this 9 kilonewton there. 9 kilonewton. Oh, okay. Ax and ay already have determined. Ax is 0, ay is 18.75. So 18.75 kilonewton. And then you have the distributed loading here, right? And the distributed loading is within this 2 meter distance, and it should be at the middle of that distance, so it should be something like this. So if you calculate, it's 12 kilonewton per meter times 2 meter, right? Becomes 24 kilonewton. Now the distance here is half of this, meaning half of 2 is 1. So okay, so if you draw the distance, this is 1 meter, this is 2 meter, and hence is this 3 meter, right? Because it's 2 plus 1. So that's the free body. Okay, no, we have the, because we need to find the normal, the shear, and the normal, the shear, and the moment. All right, so this is the shear at point C. This is normal at point C, and then this is moment at point C. Okay, so based on this free body diagram, so you need to find just FVC, MC, and NC, right? So we go to the easiest one first. Summation of Fx equal to 0. It's not always be, meaning I'm not saying that Fx will always be the easiest, but in this case, because there's no other horizontal forces, so you get NC equal to 0 straight away. And then upwards as positive, summation of Fy equal to 0. So you have 18.75 minus 9 minus 24 minus VC equal to 0. And hence we get VC equal to 18.75 plus, oh no, minus 9 minus 24. Okay, so but VC is negative, so it goes that way, so we get negative 14.25. Where's my mouse? Okay, so that's the answer. Okay, negative meaning opposite direction, right? Opposite of the one that we draw, which is the convention there. Now, what else? Okay, summation of moment about point C equal to 0. Let's consider counterclockwise as positive. So you have MC, and then you have 24 also counterclockwise, so plus 24 times 1, and then plus 9 times 4, and then minus 18.75 times 5, 6, and then equal to 0. So MC equal to 52.5 kilonewton meter, right? Alright, so that's the 3 answers requested. So question 1C then. Question 1C. Now, if you notice, the question is asking for the same thing but using the right part. So we'll just draw that part should be shorter. So we have NB, which is upwards, and we have the answer earlier, which is 38.25 kilonewton. Double check, 38.25. Okay, and then we have the distributed loading. So it's 12 kilonewton per meter times 2 meter, 24, right? 24 kilonewton. And then you have VC here and MC. Now, in terms of the distance, it is going to be 1 meter, right? Alright, so similarly, you have 3 equation of equilibrium. So summation of Fx equal to 0, taking positive to the right, so minus NC equal to 0, or NC equal to 0. Next, if you take positive upward, summation of Fy equal to 0. So you have VC, you have minus 24 plus 38.25 equal to 0. So you get VC equal to negative 14.25 kilonewton. Just double check, because you understand already the concept that the answer should be the same as above, right? So just spend several seconds. So NC is 0, VC is negative 14.25. Okay, again this is opposite direction, opposite to the drawing, right? So another one is moment, right? Summation of moment about point C equal to 0. Let's consider, let me just consider clockwise, so that the moment there become positive. So you have MC, and then you have 24 times 1 plus 24 times 1 minus 38.25 times 2 equal to 0. 24 minus 38.25 times 2. Okay, so 52.5 mc is equal to 52.5 kilonewton meter. Question D. What will happen if both 9 kilonewton force and 12 kilonewton meter per meter distributed loading are reversed in direction? Meaning what? Meaning this will go upwards, this will go upwards. What will happen? Now from the drawing you can see that the support here it prevent from movement in X and Y, so that point A will always remain there, but it allows for rotation. Point B is only support direction is only normal upwards, right? So it prevents from going down, but it doesn't actually prevent from going up, right? So basically, if you reverse this, point A will remain, but it allows for rotation, and point B will actually, meaning the whole beam will be rotating, right? Because point B do not prevent from that movement. So you can just answer as such, as long as you understand what you are answering, and the examiner can appreciate what you are saying. Where's my pen? Okay, then it should be okay. So question 1D. Okay, my eyes is already. What will happen and why? So that's the thing. What will happen and why? So what will happen is the beam will be lifted up at point B. Why? Because point A allows for rotation and point B do not prevent upward movement. Okay, that's the answer. So okay, we already almost used 1 hour, so we have to rush. So this is only part A, 1A, B, C, D, right? So let's go to question 2. Based on the platform, okay, so we have this one, platform scale in figure 2. If X, so this X, so meaning the distance is given. So X is 400 millimeter. Determine the mass of the counterweight S. So this is the mass of the counterweight. So determine determine the mass of S required to balance 100 kilogram load L. This is L. So given this is 100 kilogram, given this 400 millimeter, determine S basically, right? Alright, so for this kind of question, so if I make it smaller, can you still see? Because you need to draw free body diagram, right? So question 1E, right? So in this kind of setup, first question that I think you have to answer is, normally in trusses, first question is there any zero force member? But in the frame, you don't see normally zero force member, but you will see sometimes or many times 2 force member. So is there any 2 force member? So if you can identify here, BC is 2 force member, DF is 2 force member, and EH is 2 force member, right? So if I just draw, let me see, identifying 2 force members. So you have BC here, so let's just draw that. BC, right? BC, and then DF, and then EH. EH. Now, when it is two force member, it is either in tension or in compression, right? So if you can see how this logically work, there's weight here that will pull it down. So this is most probably in tension, right? Because it's being spread apart, or the force is trying to spread it apart. Similar with this one, similar with this one, because everything is pulling downwards. So in that case, it's under tension, right? Meaning it's being stretched. So it's under tension. So let's call this FBC. FBC. This is under tension as well. FDF. DF. FDF. And then this is under tension as well. FEH. FEH. Alright. Now to draw the rest of the free body diagram. So you have CDE here. So this is CDE, right? This is member CDE. So C is connected to BC here, and this point here, because this is like this, so it will be like this, right? FBC, and it's being pulled downward on that side, and at this point EH, so it's also connected to this one, so FEH, and also at point D somewhere there, this FDF, right? FDF, right? So that's the forces. The distance 150 millimeter, 250 millimeter. Alright, so that's one free body diagram. We'll draw another one. Okay, this one is longer, right? Okay, let's name this so that this is member CDE. CDE. And then member ABS, let's call it ABS. So you have a long member. Okay. So at point A, you have pin support, so AX and AY. At point B, it is connected to BC here, right? See here, so corresponding to this one, it should be something like this. FBC, and then it is connected to S here, downwards, right? S, and let's call it weight S, but we need letter is mass, right? Okay, that's the forces. What's about the dimension? So this is A to B is 100. 100 millimeter, and from A to point S, it is actually okay, we can use either the above or below, right? Because above is 100 plus 250 is 350 plus 150 500. If you go downwards, 150 350 500 as well. And then you add another 400x, right? X is 400. So 500 plus 400 is 900. That is from A. But if you consider from B here, 900 minus 100, 800, right? Okay, so that's the free body diagram. There's another one actually. This one, GH, right? So let's call it that. GH. Okay, so 10 already, so we have used 1 hour. So yeah, we are under pressure now. So G H is connected to EH, FEH there, so FEH. G is having pin, so you have, okay, let's consider the GX, GY, so this is point G. And then you have the weight down, which is, let's call it weight L. Okay, so what is the question given? The question given is to balance 100 kilogram load L. So this is 100 kilogram, so it is 100 kilogram times 9.81. This is already in terms of Newton. Okay, so the distance or the dimension, this first one is 150. And the next is 350, right? Okay, so that's the free body diagram. Now we can determine. So we will start here, right? Because this is where they have the value. The rest, we don't have any value of the forces. So from member, from free body diagram of GH, which is this one. So if you take summation of moment about point G equal to 0, and if you take counterclockwise as positive, so FEH times 500, 345, right? And then sorry, yeah, moment about G, right? So FEH, correct. And then minus 100 times 8.81, 9.81 times 150, right? 150, this is equal to 0. Okay, sorry for the space there. So okay, 100 times 9.81 times 150 divided by 500. So FEH equal to, okay, 100 times 9.81 times 150 and divide by 500. To 94.3 Newton. Now from there we can use, because we already know FEH, we can go to this one, right? Free body diagram CDE. So from free body diagram CDE, let's, because just to make it easier for me to process this, so I'll just take this, just put it somewhere here or somewhere here. Okay, so FEH now is known, right? Which is that one. So this one is known, right? So we want to find FBC, right? Because it's connected to the rest. So summation of moment about point D. Okay, this is point D. Correct? Yeah. Summation of moment about point D equal to 0 if we take counterclockwise as positive. So you have FBC times 250. You have minus FEH, which is 294.3 times, so 150 to 0. So my eyes is already tired so much. It becomes, it push me, the whole my body becomes sleepy. Okay, so 17, where's my FBC equal to 176.4 Newton. Now we have FBC, we can go to this one, right? Because we know FBC, we can find WS. So let me just take this. Okay. Okay. Allahumma salli ala Muhammad. From free body diagram ABS. From the free body diagram, FBC is known up here. So you can straightway do summation of moment about point A equal to 0 if we take clockwise as positive. Let's say clockwise as positive. So what you have is WS times 900 minus what's 176.4. 176.4 times distance of 100 equal to 0. 176.4 divided by 100. Okay, I'm so sleepy. Why? 176.4 times 100 divided by 900. 19.6. This one I rounded up. Oh no. 294.3 times 150 divided by 250. Wait, what? Where did I get this number? Okay, this number is wrong. Let me 176.58, right? Hence, and this is wrong as well. Astaghfirullah. So okay, let me see. 294.3 times 150 divided by 250. 176.58 Newton. So here it will be, because FBC here, so 176, so minus 176.58 time distance of 100, then equal to 0. So from here W equal to 176.58 times 100 divided by 900. 19.62 Newton. So the question asks for mass. So this is WS, right? So MS is 19.62 divided by 9.81. It is 2 kilogram. Alright. So that is question 1E, right? 2 kilograms. So yeah, you have to check. Just like that. Okay, so my eyes is so sleepy, so it's really affect my concentration and subhanallah. Okay, so we'll go to question 1F. So what does it say? Okay, X is different. X is 500. Determine L. 1 kilogram. Okay, so then S is given, we need to find L. Alright, so if you already have done the first part, and then you know, because it's the same diagram and the idea is the same, but the flow is different, so you know where to start, right? You will start at the back here and then move forward, right? So question 1F. So because what is given is S, so we'll start with that one, right? We'll start with this one. So ABS, so free program of free. Okay, let's just FBD. FBD of ABS member. So you'll have something like that. You have EX and EY. Okay, so your two force member will be exactly the same, right? So here, so you have FBC, and then down here you have weight S, but it is given that S 1 kilogram, so it is 1 kilogram times 9.81 Newton, right? Becomes basically 9.81 Newton. Okay, 1 kilogram, right? And the distance, okay, the distance will be different because X is different, right? So in this case, this is still 100. And now the distance is, because this is what, okay, it's from point E to F there, right? So it's 3, no, this whole thing is 500, and then X is 500, become 1000. But because this is 100 already, 1000, this is 900 mm. Alright, so we have this, and we want to find FBC. So summation of moment about point A equal to 0. If you take counterclockwise as positive, so we'll have FBC times 100, and then minus 9.81 times 1000 equal to 0. So FBC equal to 9.81 times 1000 divided by 100. Subhanallah. 98.1. Now we know FBC. We go to the next one, which is CDE, right? So free body diagram, member CDE. So you have the beam, and you already know FBC, right? So on that side, FBC is what the value? 98.1. I'm so sorry with me being sleepy. It cannot be helped. And then this is FDF, and then you have FEH, and then you have the dimension of 250, 150, 250 millimeter, 150 millimeter. Okay. So in this case, summation of force, because this is point D, right? Summation, not force. Summation of moment point D equal to 0. So this is point D. So if you take counterclockwise as positive, so you have 98.1 times 250. Okay, and then minus FEH 150 to 0. 98.1 times 250 divided by 150, 163. So FEH is 163.5 Newton. And then we have FEH. We can go to the bottom here, GH member, free body diagram of member GH. Subhanallah. Okay, you have GX, GY, and then you have the weight L, and then now you know FEH, right, which is the FEH or 163.5. 163.5 Newton. And then the distance is 150. Okay. 150. 350. Summation of moment about point G equal to 0. Counterclockwise is positive. 163.5 times 500 minus WL times 150 equal to 0. Okay, it's 10:20 already. We are behind schedule. 163.5 times 500 divided by 150. 545. And then the mass 545 divided by 9.81. $55.55. Not Newton, kg. Okay, so it's 10:21. We have used 1 hour and 20 minutes, and we only have one question. But of course, it's 40%, so 40% of the time as well, right? All right, so just check whether we have answered everything. One A, B, C, D, E, F. All right, now we go to question number 2. I need to stretch, so I'll use 1-2 minutes to stretch first. Otherwise, I'm so sleepy I cannot do anything. Bismillah. Okay. So question number 2. We have the diagram here. So if you can see, there's a box, there's a dimension, there's a ladder, there's this guy here. Yeah, I'm not sure what is he looking at the box. Why? Anyway, that's not important. The Detective Pikachu, this guy here, is standing on a ladder which is leaning on a box as shown in figure 3. The mass of the box is 20 kilogram and G is the center of gravity of the box. So this box, the center of gravity, and the mass is 20 kilogram, while the weight of the ladder is negligible. So meaning that this we consider is as null weight, or because it's negligible. Determine the minimum weight of Detective Pikachu required to cause the box to tip over if the contact between the ladder and the box is smooth. So meaning that there's friction here, but if this is no friction because it's smooth, right? What is the minimum weight of Detective Pikachu required to make this to tip over? So that's the idea, right? Meaning that it is impending motion, it is about to tip. What is the at that point? What is the weight of Detective Pikachu? All right. So let's go. So we have this guy here. Okay, let's just. All right. So let's go to question 2. Question 2. We start with 2A, right? So the box is about to tip over, so we'll draw the free body diagram of the box first. When is it about to tip over, meaning that the normal reaction is already there, right? Let's call this normal of the box. The friction is in this direction, of course, because it tend to be pushed in that way. So the friction is counter it, and it's about to tip over in that way. That's why N is there. And then we have the weight of the box, which is what, 20 kilogram just now. 20 times 9.81 Newton. What is that? Newton. That's the weight. And then we have this force, let's call it P, from the ladder pushing that way, right? Because it's a normal reaction. The contact here is normal reaction, so that way. The rest is dimension. So okay, so this is 1 meter, 1 meter, and this height is 4 meter, right? Okay, so we have what we need. So from here, summation of what is, let's call this point, I want to call it point O. Let's call it point O. So moment of point O equal to 0. Let's consider counterclockwise positive. So we have P times 4 minus 20 times 9.81. That's the weight down there, and 1 meter, right? Equal to 0. So P equal to 20 times 9.81 divided by 4. 49.05 was 49.05 Newton. 29.81, and also distant 1 divided by 4. Alright. Now what we want is Pikachu's weight, right? So we go on that side. So this. So we have this P, and it's already determined, 49.05 Newton. We have the weight of Pikachu. It's not at the middle, right? So it's there. That's the weight of Pikachu. And this is 1 meter, 2 meter. The height is 4 meter, right? Oh, okay. So we should have normal reaction here as well. So normal reaction here, normal of ladder, let's say. And then for friction, right? Friction will be that way, friction. What else? That's all right. So summation of, let's say this is point, what point? Okay, A. Point A, let's say. Summation of moment about point A is 0. So let's take counterclockwise positive. So we have WP times 2 minus 49.05 times 4 equal to 0. 49.05 times 4 divided by 2. Weight of Pikachu is 98.1 Newton. The question asks for determine the weight of Detective Pikachu. If the weight, then that's the answer, right? If the mass, if the question asks for the mass, then you have to divide by 9.81. You get 10 kilogram, right? Anyway, so that's part 1. We already have solved. This is the weight of Detective Pikachu needed to topple or tip over the box. Question B. Determine the condition of coefficient of static friction between the box and the floor, as well as the coefficient of static friction between the ladder and the floor, for the box to tip over when the weight fulfill the value determined in A. Now, when the weight of Detective Pikachu fulfill the value determined in part A, which is this one, right? Meaning that when detective, because remember WP here is the weight for the weight of Pikachu for the box to tip over. So it's actually the weight that caused the impending motion. Now the question asks, if the weight is exactly that at the impending motion, what is the condition for static friction between the box and the floor, as well as the ladder and the floor? Meaning that if I use different color, because coefficient of static friction will affect the maximum value of this friction, right? Also as this one as well, right? So for, okay, so let's go question 2b, right? The idea is for box to tip over, requirement is one, box not yet slip, right? So if the friction already reached the maximum value and it slip, then the tipping will never occur, right? And the second, ladder not yet slip as well, because if the width of Pikachu is big enough that the ladder already slide down, because the friction here cannot sustain, it's already slide down, the box will not tip over as well. So there's two conditions for the box to tip over. One is it's not slip yet for the box, and the ladder also not slip yet. Hence, this is why it related to mu, or coefficient of static friction. So going to use the same free body diagram, so we'll just take this, but unfortunately there's the red mark, but you just ignore that red mark. Okay, so you can just write referring to the same free body diagram above. You can label the free body diagram, but for me, because I'm doing this just in actual paper, I will not, there's no such thing as copy and paste, and I will not redraw because I can straight away use this one. However, because to avoid scrolling, I'll just copy paste on the side so that it's easy for me to compute. So using this free body diagram, the idea of this is the idea of ladder not yet slip means that F should be bigger than F. Sorry. Should be smaller, right? Yeah, F should be smaller than F max, because if F is already reaching F max, slipping already occur, right? So F. Okay, so now that's the condition, but F has a value in this free body diagram, right? So summation of Fx equal to 0 if you take positive to the right, so you have F minus P equal to 0, and P is already known, right? F should be equal to P, right? Which is equal to, because it says that the weight of Pikachu is the same, so P is 49.05. 49.05, right, Newton. Now going back to this, so if F is 4, F less than F max, what does it mean? Means that 49.05 should be less than mu. This is for box, right? Let's say box n normal, right? And normal is what? So we haven't calculated yet. Okay, I'll calculate it on this side here. Summation of Fy equal to 0, upwards as positive, so you have NB minus 29.81 equal to 0. So 20 times 9.81, what? Don't go into the exam while you are so sleepy. It's I have a story about SPM. What happened to me during my SPM when I fall asleep in the exam. It almost caused me to fail one subject. Fortunately, I didn't totally fail, but I get a very bad result, but still not fail, and I do not need to repeat my SPM. Anyway, yeah, so this is NB, right, from free body diagram. So going back to this one, so mu n mu b times 196.2, and based on this relationship, so you just bring it here. So 49.05 divided by 196.2 mu b, right? So 49.05 divided by 196.2, 0.25. So 0.25, or if you rewrite it, mu b, the condition is it should be bigger than 0.25. to 5. Right? Okay, so that's the one condition. We have another condition, ladder not slip. So we are talking about this free body diagram. Alright, so again the same story, meaning that f should be less than f max. So but we need f and first, right? So summation of fx equal to 0, 49.05 minus f to 0, f equal to 49.05 Newton. Upwards as positive, summation of fy equal to 0, and L minus WP is already known to be 98.1, right? 98.1 equal to 0, and L equal to 98.1 Newton. So for a condition that F is less than F max, or 49.05 should be less than mu L 98.1, or 49.05 divided by 98.1, 0.5, or mu L should be bigger than 0.5. So that's the two answer, right? Coefficient of static friction between box and the floor should be bigger than 0.25. The static coefficient between the ladder and the floor should be bigger than 0.5. Alright. Part C, what will happen if the weight of the Detective Pikachu fulfills the value determined in part A, meaning that the weight reach this one, meaning the weight is already sufficient to make the box to topple, but condition in part B is not satisfied, but meaning that this force is already reached, meaning that it enough to make this topple, but this mu B and mu L is not big enough. What will happen? Now, if you understand, this is question. This is question 2, is it? 2C, right? So when the weight is big enough, but if let's say mu B is how to say not bigger than 0.25, it's 0.25, right? If it's not, then actually box already slip, because the maximum friction at the bottom of the box is actually less than what is needed for the box to topple, meaning that it's already slip. Okay, but if mu L is not bigger than 0.5, then the ladder already slip. So this question, we do not know exactly what will happen, because it just say the conditions in part B not satisfied. If one of these is not satisfied, we know what will happen. Meaning, for example, if mu L is satisfied but mu B is not, then box is slip, or vice versa, right? But if both is not met, so we have to see which happened first, either box slip first or ladder slip first, right? But either way, if you write something like that, it's sufficient, because the marks is only 2, right? And normally it just want to see whether you understand the relationship of all of this, right? All right, so that's question number 2. We are moving to question number 3. So we have done 1 hour and 40 minutes. We have only 1 hour and 20 minutes, right? Moving on, question number 3. All right, question number 3. So we have this area. So determine the centroid clearly indicate the element used. So if you know there's vertical element and horizontal element, the answer from using both should be the same, but one can be longer than the other. But in this case, it's quite similar, I think. But it depends. When we do it, we'll see, right? So part B is moment of inertia. So we'll do one by one. Part A first. Determine the centroid. So let's make this bigger because we want to see the diagram. Alright. Okay, so this is question 3A. So centroid. Centroid, the equation for integration is so y, because we need to find centroid, meaning both x and y, right? Alright. So we need an element. So let's, okay, in this case, because y square equal to 4x, right? So in this case, I think it's easier to have it in terms of y, right? So let's try that one. So in terms of y, meaning that it is horizontal, because that's dy there, right? For example, if I am to draw, this is straight line, is it? Okay lah, whatever. So here, because you have y square equal to 4x, or in other words, x equal to 1 over 4 y square, right? In this case, we have y equal to 2x, or if, in other words, x equal to 1 over 2y. So if you can see here, because, okay, another way to express this is y equal to 2x power of half, right? Will that make it difficult or just the same? So the level of difficulty here is both way should not be that. It should be similar, right? Anyway, so we'll do horizontal first. Horizontal. So let's label this 1 and 2. Let's use it. This one, meaning this is equation 1, equation 2, equation 1. So with that, let's see. So this is 2, this is 1, right? So this one is dy. This one is x2 minus x1, right? Or in other words, if you because x2 is this one, so it's 1 over 2y minus, and x1 is this one, minus 1 over 4 y square, right? Okay, so hence from here you can see that, okay, if you see this one, x wave, y wave here. So let's do one by one. So x wave would be x2 plus x1 over 2, right? And while y wave is y, and dA is basically x2 minus x1 dy, or here we have simplified already, 1 over 2y minus 1 over 4 y squared dy. Alright, so yeah, and so x bar, okay, the limit, if you do this one, it's from 0 to 2, right? The limit. So integration from 0 to 2, x wave is x2 plus x1 over 2, and then dA, I just write that whole thing first, I think. X2 minus x1 dy over 0 to x2 minus x1 dy. Okay, my writing is it too big? Okay, so here if I take half outside, so we'll have x2 squared minus x1 squared dy over x2 minus x1 dy. So integrate to half. Okay, x2 is, which one is 2? This one, right? Yeah, so 1 over 2y. 1 over 2y, but because of square there, 1 over 4 y square. Minus 1 over 2 x1 square, x1 1 over 4 y square, so 1 over 16 y to the power of 4 dy. Divide by integration 0 to 2, 1 over 2y minus 1 over 4 y squared dy. So if you integrate, this become 1 over 8. So y power 3, so 1 over 3 minus 1 over 32 here, and then 1 over 5, 1 over 5 of 1 over 5. 0 to 2. Subhanallah. One over 4 y square minus 1 over 12 y cube. 0 to 0 to. I'm not sure whether it's obvious in the video. I'm micro sleeping or something right now because it's just I just shut down. Subhanallah. Okay, so we will not have enough space here. So here 1 over 24 times 2 power of 3 minus 1 over, what is this, 5 times 32, 5 times 32, 160, 2 power of 5 divided by 1 over 4 2 square minus 1 over 12 2 to the power of 3. So we get 2 over 15. Over 3. Wow, I'm so sleepy, subhanallah. 2 out of 5, 2 over 5 or 0.4. Okay. Okay, no, that's not the full answer. That's just x coordinate. What about y coordinate? Okay, so y coordinate, so the equation is already there, right? So we can straight away. So y coordinate is integration y wave dA, okay, over y dA, integration of dA. So it's still 0 point integration from 0 to 2. Y wave is y. And then dA is let me just copy this. It's dy, right? Yeah. Wait, this dy is already outside, right? Okay, so to integrate, okay, first expand first. All right, so what is this? Okay. Okay, when you are so sleepy, your processor becomes so sluggish. It's avoid going to exam in this state. It's not good. Subhanallah. Okay. What am I doing? My processor doesn't work. Okay. Y square y cube. So 1 over 6 y cube minus this become 1 to 4 for 1 over 16 y to the power 4 from 0 to 2. Alright. 1 over 4 y to the power 4 what y to the power of 2 minus 1 over 12 y cube 0 to 2. So it's basically 1 over 6 to power of 3 minus 1 over 16 to the power of 4 divide by 1 over 4 2 to power of 2 minus 1 over 12 to the power of 3. One divided by 6 times 2 power of 3 minus 1 divided by 16 times 2 of 4 1 over 3. Is this correct? 1 divided by 4 times 2 over 2 minus 1 divided by 12 times 2 4 of 3. Wait, I think there's a mistake here. Let me double check. Okay, like it's 1 over 6 y cube. Okay, 1 over 16 y to the power 4. Okay, so 1 divided by 6 times 2 power of 3 minus 1 divided by 16 times 2 power of 4. Okay, it's 1 over 3. So is there any mistake here? La haula wala quwwata illa billah. 1 over squared minus 1 over cube. Okay, the A should be fine, right? The A 1 over 2 y minus 1 over 4y square. Okay, I'm having to check where did I make a mistake, because the answer doesn't make sense. Oh, is it 1 meter? Okay, my processor is so slow that I thought of something else. Okay, in this case, what am I doing? X, Y equals 0.4 1 meter. That's the answer. Okay, now let's try. Of course, you have to do only once, but let's try. Let's try using, let's say, question 3a. Do I have the time to do this? Because we have another 1 hour, 4 minutes, and I'm trying to do this. Okay, let's just do it, right? So centroid. So, and trying to use vertical element. So this is 2, this is 1, and this one is y equal to 2x, x equal to half y. In this case, y is equal to 4x, so x become 1 over 4 y square, y equal to 2x equals to 1 over power of 2. Now if you use vertical element, this is x with y with, this is dx, and this height is x2 minus x1. So x wave is x, y wave is y2 plus y1 over 2. Okay, while dA is x2 minus x1 dx. Wait, it's not x2, astaghfirullahalazim. It's y, right? y2 minus y1. What am I doing? So similarly here, y2 minus y1, y2 minus y1. I'm so sleepy, ya Allah. Okay, forgive me for all this. I hope this still watchable, because you know, my state currently might be very distracting, maybe distracting. Anyway, so dA is y2 is here, so 2x of half minus y1 is here, so 2x, right? dx. So that would be the case. Bismillah. So for x bar, we haven't write the equation. Okay, so integration of x with dA over integration of dA. So the limit will be, in this case, from 0 to 1, right? This goes down to 1, so it's from 0 to 1. So from 0 to 1, x wave is x, right? X dA is 2x power of half minus 2x dx, divided by integration 0 to 1, 2x half minus 2x dx. So before integration, so again, ya Allah, 2x 3 over 2 minus 2x square dx. Okay, so 2 times 2 over 5 x 5 over 2 minus 2 over 3x power 3. This is from 0 to 1. What is this? Ya Allah. 2 times 2 over 3 x 3 over 2 minus x square 0 1. Okay, so 4 over 5 times 1 5 over 2 minus 2 over 3 times 1 power 3 4 over 3 1 3 over 2 minus 1 squared. Okay, so 4 divided by 5 times 1 minus 2 divided by 3 divided by 4 over 3 minus 1. So you get 2 out of 5, which is 0.4. So as you can see, it is 0.4, which is the same. This is for x bar, right? I think I remember 0.4 and 1, right? So we already have 50 minutes left. So anyway, let's just do what we can. So this is a simulation of how exam will be if you are extremely sleepy. Okay, now y wave is y2 plus y1 over 2. So y2 minus y1, y2 plus y1, right? And then dA is y2 minus y1 dx. y2 minus y1 dx. y2 minus y1 dx. My writing is even becoming worse and worse. y2 squared minus y1 squared dx over y2 minus y1 dx. Okay, so if you exchange y2 into x, y is 2x power of half. 2x power of half. 2x power of half. So become 4x, right? Yeah, y squared. Basically, y squared is 4x. Yeah. And then minus half times y1 square. y1 square. Y is 2x square becomes 4x square, right? dx. y2 is 2x half. And then I hope you can still follow. Anyway, this becomes 2x square, right? Because 4 divided by 2 is 2, and then divided by 2 is 1. Okay, and then minus 2 over 3 x3, right? And then below 2 over 3 x3 over 2 minus x square. So yeah, exactly the same as before. So you have x bar what so the answer is the same as before, just that we use both element, right? Alright, so of course in the real exam you don't need to spend all this time to solve using both element. It's not needed, but this is just as illustration. Okay, this is actually 3a, right? Because 3b is moment of inertia. So yeah, so we'll have this is 3a, right? So let's just do this one. TB is determine moment of inertia about x-axis of the shaded area shown. Clearly indicate element used. Alright, for moment of inertia, okay, for moment of inertia, you have to understand the equation based on the element that you use. Right? For example, we need to find Ix, right? So Ix equal to integration of y squared dA, provided that you use this element, right? So we'll do that first. We'll do this and using this equation, right? So this one, right? So this, if we label this 2 and 1, right? So this become x2 minus x1, and then this is dy, which means dA is x2 minus x1 dy, right? And based on the equation, this is equation y squared equal to 4x, so x equal to 1 over 4 y squared. This is y equal to 2x, s equal to y over 2. Right? Means what? Means the A is x2 is 1 over 2y minus 1 over 4y squared. Alright, so we have dA. Now if you have integration like this, it's from 0 to 2, right? Because that way. Okay, so Ix equal to integration of 0 to 2y squared dA is 1 over 2y tolak 1 over 4y squared dy, right? So integration from 0 to 2, 1 over 2 y cubed minus 1 over 4 y to the power 4 dy, 1 over 8 y to the power 4 minus 1 over 20 y 5 0 to 20. One over 8 2 to the power 4 minus 1 over 20 2 power 5. 1 divided by 8 times 2 power 4 minus 1 divided by 20 times 2 power 5. 2 over 5. Oh, wonderful. Oops. So it should be meter 4, right? Okay, so we have solved that one. Now, given the time remaining, If I'm to try using vertical element, oops, why is it that way? If I'm to use a vertical element, it will use quite significant time that we will not be able to finish before 12. Wait, we start at what time just now? 9:30, right? Oh, so maybe we have time. Let's try. What if we use vertical element? But if you want to use vertical element, you have to understand parallel access theorem, right? So if, for example, let's say, if using vertical element and parallel axis theorem, and what by parallel axis theorem is if you want to use this one, meaning that if this is at the axis, so Ix is 1/3 bh cube, this one, right? If this is b and h, so if you want to use this one, you have to use composite, meaning that if you use vertical element, it will be like this. Right? Allahu Akbar. This vertical element, it's exactly, actually it is this vertical element minus this vertical element, right? Where if this is line 2 and this is line 1, so this is line 2, this is line 1, so that if you use this, you can do it, right? So if this is the case, because the equation will be Ix equal to integration of dIx, right? And dIx we get from this parallel access theorem, meaning that because in this case, so it becomes integration of 1/3 y cube dx, right? 1/3 y cube dx, because dx is b, y is h, right? So using that, if you want to use this, so Ix becomes, okay, so for this one, okay, the limit will be the same from 0 to 1, right? But the equation is different, right? So here, the first one here, it becomes integration from 0 to 1, 1/3 y cube, okay, this might be, okay, y is what? This, okay, wait, which line is this? This is this line. So y is, okay, let's put it here so that it's not confusing. This line 2 is y square equal to 4x, right? And then this line 1 is y equal to 2x, correct? Alright, so from there, y is 1/2, not 1/2, 2x power of half, right? So in that case, 2x power of half, then power of 3 dx, and then minus from 0 to 1, 1/3 y is 2x, 2x power of 3 dx, right? So if you solve this one, okay, we have to resolve it first. So 1/3 times, okay, 2 power of 3 is 8, right? 8, and then x 3/2, right? Dx minus 1/3 8 x cubed. Okay, so if you integrate, okay, this is 8 over 3, right? 8 over 3, then x 5 over 2, 2 over 5, minus, okay, so minus 8 over 3, 1 over 4, x to the power 4, 0. Eight divided by 3 times 2 divided by 5. 16 over 15 minus 8 divided by 3 times 1 divided by 4. This is 0, right? 2 over 3. Two over 5. 0.4. Is it the same? Yep, it is the same. So this is 0.4. This is 0.4 as well, right? So the answer will be the same if you use vertical or horizontal, but in this case horizontal is straightforward like this. Vertical, you have to understand parallel axis theorem as well as composite, right? Okay, so that's question 3a. What about 3b? No, sorry, this is question 3b already. MashaAllah. Okay, so let's go to question 4. Part A. Determine the centroid of the shaded area. Clearly indicate segment. Okay. Right. So question 4A. Okay, I need to stretch up. Okay, so did some stretching a bit. Okay, so let's divide the area. Okay, so we need to find centroid, right? So basically centroid, x bar equal to summation of x with a over summation of a, y bar equal to summation of y with a summation of a, right? So that equation, so let's consider this thing, right? So we have basically, if you see, it's something like this, that but 1, and then we have another 1, and then minus something there, right? So it's basically this, basically triangle plus rectangle minus the circle. That's basically it. So we can do this by using the table, right? So segment, so let's say this is segment 1, segment 2, segment 3, right? And then you have the area, and then you have x with the coordinate of centroid, y with coordinate of centroid, and then x a, y a. Okay, let's go to segment 1. So, okay, segment 1 is the triangle. Segment 1, right? So the area is simply, okay, based on this triangle. So normally I on paper it's easier to sketch, because this okay, where is it? So this 7 minus 3 is 4, right? And then this ten minus 1, it's 9, is it? Because this is only 1, right? This whole thing is 8. Okay, so area is half times 4 times 9 equal to 18. Now, okay, this one here is 1/3 of 4, right? So 1/3 times 4, and then you have to add another 3 on the side. So add another 3 on the side, 13 over 3, or 4.33, right? Okay, so it's a negative 13 over 3, or negative 4.3333, right? Okay. Y wave is 1/3 of 9 is 3, right? 3. Okay, so that's number 1. We'll do the calculation later. What about segment 2? The rectangle. So the area is 8 times 10 equal to 80. X wave is, okay, this is 8 divided by 2, 4, so it's 1. And then height is 10, so it's 5. Segment number 3, the circle here. So pi r square, r is 1, pi r square, so become pi. But this is negative, right? So negative pi, negative sige. Negative pi, what am I saying? I think I fall asleep. Okay, so x is basically, what is this? 3, so meaning this is 2, right? So 2, and then height is 5. Alright, so based on that, we can calculate the rest of the column. So 18 times, okay, just check the positive and negative. Area, all are positive except whole is negative, okay. X coordinate, for this one is negative, obviously. For this central, for this rectangular, it's positive, that positive, okay. Y, everything is possible, positive. Alright, 18 times 13 divided by 3, 78. So minus 78 there. 18 times 3, 54. So this is 80, this is 400. This is negative 2 pi, negative 5 pi. Okay, so area, we sum everything up. 18 plus 8, 18 plus 80 minus pi, 94.8584. X wave A minus 78 plus 80 minus 2 times 4.2832. Okay, let's finish this. 438.292. Okay, the space is not enough. Okay, so based on the equation above, x is 4.2832 divided by 94.8584. 4.2823 divided by 9, 4.8584. Wait, is this positive or negative? Negative, right? So my calculator doesn't. It does. I didn't realize it's negative. So okay, negative 4.2832 divided by 94.8584. Wow, negative 0.04515. Now, y bar equal to 438.292 divided by 94.8584. 438.292 divided by 84.8584. 4.6205. So centroid is negative 0.04515. This is if you not round off. Okay, that's the answer. Just take a look if it makes sense. This whole thing, if the center can be something here, so negative 0.04 or negative 0.05 is close to here, seems possible, right? 4.62 in terms of vertical, so 4 is somewhere here, right? So is it logical? I think so. Yep, so that's the answer. So moving on to the question for B. So question for B, determine the center of mass of homogeneous rod shown in figure 6. Clearly indicate the segment and equation used. Now in this case, it just give it's basically line. So it's composite of line, right? It doesn't have any dimension mentioned, etc. So you just consider it as a line. So in that case, wait. So in that case, question for B. So you have 3D, right? This is 3D, right? So let me just put it here. Okay, we cannot see then the dimension. Yeah. All right. So basically, x bar equal to summation of x with, in this case, length, right? Summation of length, because it's just a line, so you just find the centroid and that multiplied by the length, because it's basically if you have the cross section, it's just basically area times length to get the volume. But now we consider everything is homogeneous and standard cross section area, so line is sufficient. So similarly y equal to summation of y with L over summation of L, z summation of z with L over summation of L, right? So we will have the table segment area x with y with z with x a y a z a. Okay, so in this case, if we have segments, so we have to indicate first. So how okay, let me, how to do this? Okay, let's, because it's basically like this, like this, like this, like this, like this, right? So let's say this is 1 2 3 4 5. Okay, so looking at that, segment 1 here. Okay, you have to be clear what is the axis then. because x-axis is here and x-axis is in that direction, so I show y and z so that you can remember x. So yeah, so area, okay, not area, then it's length, right? Length. Length in meter, right? So the length is simply 5. X coordinate is 3. Okay, we are talking about the centroid, right? X coordinate is 3. Y coordinate is y coordinate 2.5. Z coordinate is 0, right? Now segment 2, length is 3. X coordinate is 1.5. Y coordinate is 0. Z coordinate is 0. Segment 3, length is 6. So it has some value to Z, right? So Z, you have 3, X 0, Y 0. Let me just shift this. Segment 4, 4 meter. No, X, Y is negative 2. Z 6. And segment 5, 1, 2, 3, 4, 5, right? Length is 6. X is 3. Y is minus 2. Z is 6. Okay, so if we just do the calculation. Okay, 5 times 3 is 15. 5 times 3, 5 times 2.5 is 12.5. 0. This is 4.500. 0018. 0 minus 8, 24. 18 minus 12, 36. Okay, so if you add all of this, you get 5 plus 3 plus 6 plus 4 plus 3, 24. 1.5 plus 4.5 plus 18, 34. Wait, that's not 1.5. So yeah, the way we write on paper should be clear. So it's 15 plus 4.5 plus 18. $37.5. What am I doing? 12.5 plus 12.5 minus 8 minus 12 minus 7.5 minus 7.5. 36 plus 24 plus 18, 78. Okay, so this I'll leave it somewhere there. Okay, so x bar equal to 37.5 divided by 24. 37.5 divided by 24. 1.5625. Y bar is minus 7.5 divided by 24. 7.5 Divide by 4. Okay. I need some strong coffee or something to avoid falling asleep. 3125. Okay, this is, let me double check afterwards. We have to double check everything, right? I think when I'm sleepy, it's bad. 78 of 24. .25. Now, see if it's logical. This is quite more difficult to see logical. X is 1.5, meaning it's in somewhere here, right? In that region, it seems plausible because on the left side and on the left side seem to have the similar. For y bar, it's actually negative here. It's very small, which we have to check on that because the lower part seems to be bigger, right? So it means it may be a bit more, but I don't know. Z 3.2, so it's halfway and a bit more because yeah, on this side is longer than that side. So just to double check everything. Oh, this is a fatal mistake. This y, right? Because I divide by 2. I'm not sure why I divide by 2. So 6 divided by 2, 6 divided by 2 is 3, and then you should just take 6 and 4, right? So it will affect minus 19.5 minus 19.5 divided by 24. What am I doing? Astaghfirullahaladzim. 0.8. I'm so sleepy. If it's not obvious yet. Okay. Astaghfirullahaladzim. So 1.5625 minus 0.8125, 3.25. Okay, my 5 is already becoming like what? Anyway, this is 5, right? Right, so that's the final question. Now, I think I started answering this question at 9:30, right? Is it 9 or 9:30? I thought it's 9:30, right? Because 9:30, 10:30, 11:30, 12:30, if I'm not mistaken. If that is the case, we have more than half an hour left, like 40 minutes left, 42 minutes left. And I finish even by doing more than what I need, right? Meaning that because okay, let's just take a look. For this one, I actually use both. Okay, for B here, I actually use both element, hence twice the work. For this one, centroid, I actually use both element as well, so twice as work as well. For this one, okay, this one no problem, right? This one, is there any issue? No. Right, so yeah, it's very doable, this exam, and hence I think that's why during the exam percentage that pass is a bit more than normal, I guess. Anyway, I'm so sorry for the quality of this video, the quality in term of me doing this. I'm not sure. I hope it's still beneficial. Because sometimes I talk and then I doze off, etc. So I hope it doesn't uh, become too distracting or too disturbing to watch or something that affect the learning process. Anyway, I hope now if you have seen simulation, my previous or other exam simulation videos, you might notice that this exam is not as hard or as difficult as some of the others, right? So that's basically the randomness of the exam that we are taking. Sometimes the lecturer choose certain topics, certain type of questions, certain, I don't know, diagram like this that may scare some student, or I don't know if any student actually when they look at this uh, they got distracted and they want to catch all the Pokemons, and I don't know, because they couldn't find any other Pokemon except this one in this diagram, right? So they cannot catch them all. Anyway, I'm so sleepy already. I'm not sure what I'm saying already. So hopefully this is beneficial. Thank you for watching, and all the best in your study.